All right, today we're going to do part one of these notes, and then tomorrow we'll finish them up. So we are in section 5.2, which is right triangle trigonometry. So today should be a little bit of a reminder, maybe a little bit more in depth than you went in geometry. So hopefully you remember Sohcahtoa. Remember, this is to help you remember how to set it up. So stands for sine is opposite over hypotenuse. Sine is opposite over hypotenuse. So we had sine, cosine, and tangent, right? Cosine was adjacent over hypotenuse, and tangent was opposite over adjacent. We also have cosecant, secant, and cotangent. Now cosecant, notice all it did was it flip-flopped. Instead of opposite over hypotenuse, now it's hypotenuse over opposite. So sine and cosecant go hand in hand. You just have to flip one to get the other, right? They're reciprocals. Same thing with cosine and secant, right? This is adjacent over hypotenuse. This is hypotenuse over adjacent. So once you have one, you can just flip it to find the other. And then tangent and cotangent go together as well. This one is opposite over adjacent. This one is adjacent over opposite. So when you hear these words, I do want to talk about them first. So it's all in reference to an angle. So here's my angle theta. Opposite would be across from. So opposite would be across from. Your hypotenuse is always across from the right angle. So you can label that first if you wanted to. And then adjacent is next to. So here's my theta. Adjacent is right next door to it. Or you can label hypotenuse and opposite. Adjacent's the one left over. So let's set up some functions. So here we have a triangle. Here's my theta. The issue is they didn't give us all the side lengths, so we might have to use some Pythagorean theorem to find the third side. So let's do Pythagorean theorem, a squared plus b squared equals c squared. So we have 3 squared plus 4 squared equals c squared. And 9 plus 16 gets me 25. And the last step is to take the square root. You get c is 5. So we know that this side is 5. Now we have all of our side lengths. Now we can set up. So if you want to, you can go ahead and label, this is my hypotenuse, right? Here's my right angle, travel across. Here's my angle, theta, travel across, that's opposite. And what's left over is your adjacent. Adjacent means next to. All right, so let's set them up. Sine is opposite over hypotenuse, so 3 over 5. Cosine is adjacent over hypotenuse, so 4 over 5. And tangent is opposite over adjacent, so 3 over 4. And then we're going to find cosecant. Cosecant. All you have to do is flip. So instead of opposite over hypotenuse, it's hypotenuse over opposite, so 5 over 3. The reciprocal. Secant. Theta. Instead of 4 over 5, it's 5 over 4. And cotangent, instead of 3 over 4, it's 4 over 3. So pretty straightforward. Make sure you're using Pythagorean theorem to find those missing sides though. Same concept over here, we're missing b. So a squared plus b squared equals c squared. So we have 1 squared plus b squared equals 5 squared. 1 plus b squared equals 25. Subtract 1 from both sides. And you get b is the square root. Take the square root of both sides, square root of 24. Now we do want to reduce this. So 24 I know is 4 times 6. The reason I did that, the square root of 4 is 2. Take it out. 6 stays inside. So we do want to reduce that radical. So here it's 2 root 6. And now you can set them all up. Sine. Oh, I forgot to label. Sorry. Here's your right angle, travel across. That's your hypotenuse. Here's your theta, your angle, travel across. That's your opposite. And what's left over is your adjacent. All right, so the sine is opposite over hypotenuse. So 1 over 5, 1/5, which means cosecant is 5 over 1 or 5. So again, they go hand in hand. It's pretty straightforward here. Cosine is adjacent over hypotenuse, so 2 root 6 over 5. And then secant, again, goes hand in hand. Oops. Secant goes hand in hand. It's just the reciprocal, 5 over 2 root 6. Now, there's a little no-no happening here. So remember, we can't have a square root in the denominator, so we do have to rationalize. So to rationalize, we're going to multiply top and bottom by root 6. So we get 5 times root 6 up top. And then root 6 times root 6 is root 36. The square root of 36 is 6. So we have 2 times 6 is 12. So one more time, root 6 times root 6 was square root of 36, which is just 6 times 2. Got me 12. All right, let's move on to tangent. Tangent is opposite over adjacent, so 1 over 2 root 6. And again, here's your no-no. So we're going to multiply top and bottom by root 6. You can't have a square root in the denominator. So up top we have 1 times root 6. Here we have root 6 times root 6, which is the square root of 36, which is 6 times 2 is 12. So there we go. And cotangent. Now, a little trick of the trade here. If you flip this one, you're going to wind up with a root in the denominator, and you're going to have to rationalize again. When you could just go back to the beginning and flip the original before you rationalize, because that's all you're going to have to do here. 1 over 2 root 6 becomes 2 root 6. Oops. Oh no. Sorry about that. 2 root 6 over 1, which is much easier. Now, you would have got the same answer had you rationalized, had you flipped this and rationalized. It would have just taken you a little bit longer to get there. So sometimes if you rationalize like here, I don't want to flip this because there would be a root in the denominator. I can just go back to here before I rationalized, flip it, and there's my cosine. So again, look, don't make more work for yourself. Don't make more work for yourself. So then you also should have learned about special right triangles, 45, 45, 90s, and 30, 60, 90s. And these were your formulas. This was x, x, x root 2. This was x, x root 3, and 2x. But those are your ratios. Okay. So here they want us to find cosecant, secant, and cotangent. So remember, cosecant went with sine, right? We just flipped the sign. So let's find the sine of 45. Here's 45. Sine is opposite. Sine is opposite over hypotenuse. So 1 over root 2. So cosecant should become root 2 over 1. Secant. All right, secant goes with cosine. So remember, cosine is adjacent over hypotenuse, 1 over root 2. We're going to flip it, and we get root 2 over 1. And cotangent goes with tangent. So tangent was opposite over adjacent, 1 over 1, and when you flip it, it's still 1 over 1, so it's just 1. Next one, they want the tangent of 60. So the tangent of 60. Toa is opposite, so opposite is the square root of 3, over adjacent, which is 1. Square root of 3 over 1 is just root 3. And tangent of 30. So again, 30 opposite, tangent is opposite over adjacent. Opposite is 1. Over adjacent is the square root of 3. Here you do have to rationalize. So you're going to multiply top and bottom by root 3. So here we got square root of 3. And in the bottom, root 3 times root 3 is root 9, which is just 3. All right, last but not least for today. So we kind of already talked about the reciprocal identities. So basically, if you're trying to find cosecant, it's 1 over the sign. Just whatever the sign is, flip it, the reciprocal. Same thing here, secant, flip the cosine. So these are just your reciprocal identities. We've been talking about these all along. Quotient identities we haven't talked about. So tangent is sine over cosine. So if you ever want to find tangent, you can put the sine over the cosine to find the tangent. Same thing for cotangent, just flip them. All right, so it's cosine over sine in that case. So where are we going to use these? So look at stuff like this. Given sine of theta, so we have sine of theta is 2/3. And we have cosine of theta is root 5 over 3. So right now you can use those reciprocal identities and you can say, well, if the sine is 2/3, then the cosecant is 3/2. All right, so reciprocal. If cosine is root 5 over 3, then secant is 3 over root 5. Now that one you do have to rationalize. You can't have that square root in the denominator, so we're going to multiply top and bottom by root 5. So we get 3 root 5, and root 5 times root 5 is the square root of 25, which is just 5. So that one took a little bit more work, but same concept. So those are your reciprocal identities. Now to get tangent, we're going to use that quotient identity. And it's sine over cosine. So the tangent of theta is sine, which is 2/3, over, make this a little solid line here, over cosine, which is root 5 over 3. So we're going to do a keep, change, flip, right? We're going to, instead of division, we're going to multiply by the reciprocal. So we've got 2/3, keep, change to multiplication, and flip. That's a 5. It looks like our 3's cancel out. And we have 2 over root 5. Now, unfortunately, we do have to rationalize this one. So we're hoping that that would have got us the answer, but unfortunately we have to rationalize. So we're going to do root 5 on the top and the bottom. And we got 2 root 5 over square root of 25, which is 5. Now, cotangent, instead of doing all of this again, you don't have to do cosine over sine again. You already got tangent, so use your reciprocal identity again. So I'm not going to put a, I'm going to go back to here before we rationalized. All right, we're going to go back to right here. Because remember, that was our answer, but we had to rationalize it. So instead of 2 over root 5, cotangent's going to be root 5 over 2. And again, you could have found that by doing cosine over sine as well. All right, so that's it for part 1. Tune in tomorrow for part 2.